Well, welcome you to Migros or MGB. Just to a quick overview that we talk a little bit about organization. So maybe some of you haven't heard about Migros or how it's structured, but just give you a quick intro. And then we talk about the architecture, which is the basis of the main topic, which is then the SIEM Use Case management. Like details about us, you can most. Sorry? Oh, sorry. There you go. So details about our job history, experience, or whatnot, you can read on LinkedIn. But maybe like that was relevant to us is, well, I really still shop at Coop, so but I still love working for Migros.
And with that, you also know this is Pascal, and I'm Roger.
Excellent. All right, so let's get started with the Migros universe. So we're a federal organization, so we have like lots of sub-departments. So we have like our 10 organizations which cover the regions within Switzerland. Then we have a service layer, which is MGB, which is the orange part. So we're servicing out anything from IT to sales and marketing in that layer. And then we have like all the labels, which you can see on the bottom part, which belong to the Migros universe. This is exciting, but at the same time also the difficult part. Like we have over 250 companies, or we call them partners, and that makes the job of a centralized organization really difficult because you have different ITs, you have different processes, and we have to interact with them with a centralized platform. And that's what we're going to talk about today.
Excellent. Yeah, first of all, to give you an overview how our architecture, Elastic architecture looks like. So it's got the base for then the SIEM topic on top of it. As you can imagine, 250 partners, so we need to build a platform like an MSSP would do. So we have quite a lot of infrastructure. So let's start with what we call the partner clusters. So for every partner, we have a dedicated Elastic environment. This is for separating all the data. So we have, you can say, a basket of data for every partner because every partner has different applications. And also with that, we separate the EDR fleet. So we are also using endpoint security of Elastic, and the whole fleet management is per partner only. So we have several of them. We even have kind of shared partner clusters, which means we have, for example, firewall logs we collect once for the whole Migros environment, or Office 365, Azure logs are all fetched by the same clusters and then assigned virtually to the partners itself. Also, this means for every partner, we have kind of a log collection setup. I will talk later about that a bit. We have the fleet infrastructure, which I mentioned already. So the integration server, as Elastic calls it in the cloud service. And on top of it, we do our whole magic or logic. It's our core layer, and we call these the core clusters. And that's where the whole SIEM logic actually applies. We use cross-cluster search to search through all the partner clusters. And as I said, yeah, here is also the SIEM use case, or the alerting part. To manage this big fleet of Elastic clusters, we built our own config management. With that, we have several Git repositories for that. One for the core clusters, one for all the partner clusters. We have a dedicated one for EDR, but you will see a bit more. And with that, we can have shared configuration, but also dedicated partner configurations. And yeah, It also helps us to ramp up a new cluster very quick. So new cluster is more or less adding the right entries in the Git repo, run the pipeline, and a new cluster is almost ready. Let's have a quick look at the log collection. It's a very simplified picture. We use Logstash. Obviously, we use Elastic Agent depending on the integration, on what data we fetch. This is an example where Elastic Agent fetches the Office 365 logs, the Azure logs. Depending on the applications, we have different TCP, syslog listeners, HTTP listeners. We also use Kafka in between to, let's say, have a buffer, message broker. This is especially important for applications which generate a lot of logs, like firewalls. So we need them to break the peaks of the logs. And yeah, in the back, everything is then fed into the respective Elasticsearch cluster. So the tool chain we use, it looks very basic. We have Elastic Cloud for hosting. Everything is in Elastic Cloud, all the Elastic environment at least. We use GitLab in Migros for Git repositories, and we heavily rely on the CI/CD pipelines of GitLab to push all the configurations. And we use Python and YAML, like almost everybody does nowadays, but we are also YAML engineers. And yeah, that's basically it. Short picture of how Elastic Cloud looks like for those who never used it. So it's very nice service. Click on create deployment, and within a few minutes you have your cluster ready. Yeah, we have different sizes. We have everything controlled there. We set up the cross-cluster search, everything almost there. Then for the configuration management, as I mentioned, we have multiple Git repositories. This can look like this. This is a screenshot of the repository we have for the partner cluster management. And as you can see, we have basically one folder for, you can say, each API endpoint on Elastic or configuration part, like cluster settings, enrich policies, ELM policies. Yeah. We have, and that's now the custom part, we heavily rely on YAML magic. It's anchors and aliases to put together the right configuration snippets for each cluster. So as an example, we always have, this is the configuration for the index templates. So we have like a default config we push to all customers, to all clusters. We can inherit this default config for the clusters where we use EDR. That's just by linking the YAML anchored. And as you can see for here, we have SLC CDC test as a test system, which uses the EDR inventory, which means all the configuration snippets for this part and also all the default templates. So you see some, that's not by accident, that's, yeah, as you can imagine, one of our partners. The configuration snippets itself is very basic. It's mainly the post body you would also send if you use the API itself. A bit formatting, and that's it. Then I don't know if you're familiar with GitLab. GitLab CI/CD pipelines is very similar to GitHub work actions, work whatever. So we have a CI/CD job configuration. It's also again a YAML file. We use this concept of parallel metrics jobs, which means we we define one config push job and run it then for every single cluster we have. Also, we have different trigger rules. Some trigger on merging a merge request on the main branch. Some trigger with a schedule pipeline every hour. Yeah, depending on the needs. A simple that this trigger job then triggers another job, which calls our config manager for the specific resource we want to manage. And when you run such a job, this looks like this. And also, onboarding a new cluster means adding a few lines to the GitLab job file, and it's basically done. I don't share the whole Python script because it's too long, but it's only about 500 lines of code. But we use black formatting, and as you can see, it needs more lines than usual Python code. So it's a bit less than 500 in F. But it's a fairly simple script. It's basically a REST API client that can manage these different types, handle roles, role mappings, etc. And you might ask, why not Terraform? Two simple answers. Back then, when we started with that setup, the official Terraform provider was not ready yet, or didn't support our use cases. And also, multi-cluster management with inherited configurations is, at least in my or our opinion, much more complex than this inheritance we have in YAML. And well, you never know. We are in touch with Elastic, and we keep an eye on it. So we really already tested out stuff with Terraform. Some things are not ready yet, and we are waiting for feedback. Open issue. Yeah, that's basically it from the architecture part. I would say questions at the end is probably easier.
Let's do that. Thank you, Roger. So let's continue with our SIEM use case management setup. So quick intro, hopefully like not too uninteresting to the most of us of you, is like for us we define SIEM use cases that in our context it's really a single definition of an attack scenario, which we then want to monitor against, and then have like predefined actions an analyst can run. So it's like a definition we use. Other companies use a different kind of definition, obviously, but this is really important for us, how we set up the whole architecture around it, the processes around it, so that it works for us. That you might know, which is simple SIEM rule. So you start with a title. This is customized to our needs. We have a description. We do have the criticality of that particular rule. We do have a reference to MitraTech. We'll also talk a little bit about that afterwards. We have tags we use for our processing, which, for example, is playbook reference, and also mail templates. We use this in our automation platform to automate tasks. The rule definitions, which is here like fairly simple, obviously, and then we have the schedule of the rule itself. I think a really important part, and this is like the question every SOC organization or cyber defense organization has to ask themselves, is what kind of rules do we run? Like what kind of coverage do we need? And it's really important that every organization defines this for themselves. Like Migros is a bit difficult because it's like not one industry, like we are in all industries. So our coverage needs to be a bit broader than say a company working only in a singular industry. And so it's really important that like we advise that there's a structured way of defining a roadmap. What kind of coverage do you want to need? What kind of risk you want to cover with your monitoring? And that's obviously an example of what we do, but we have devised in our automation the map, like the production of the map is done automatically. So we always know at the time of deploying a rule what kind of coverage we have. Kibana, in the meantime, has included that in a dashboard as well. So it kind of became a little bit obsolete, but we still like devise this because we also link this to our roadmap design, which is then mapped against. So for example, we always can show what our target is for the end of 24 and then see where we are with our current rule set and can show what kind of gaps we have. So why do we want to manage SIEM use cases? I mean, for one, it's that you have a proper lifecycle process. And for those who work in SOCs, for example, like if someone just edits a rule and something happens and you can't, for example, roll back, or you don't know where a change or why a change occurred, it's really important for us that we manage that. The other part is also that we have a playbook association, so we know exactly for a single use case what needs to be done, like what kind of actions need to be rolled out, when is the threat contained, so all of that needs to be directly linked. So if you just install, say, Kibana and deploy rules, well, you generate a lot of alerts, right? But you don't have a guided way of how to fight against those threats. We also want to have an integrated rule testing. So just activating something and not knowing what happens is not a good practice. Audit capabilities, obviously, when you have this in a Git repository, you can always track your changes. We have a peer review by design, so checking that in a repository, and then you do a merge and approval that also links that and provides this by the design of the process. That's now kind of a little bit of obsolete because that's what Elastic provides as well. We want to have a linkage to the MITRE coverage we want to achieve. And obviously all the benefits we get by using CI/CD principles. Using the same pictures we saw before. So what quickly, like in a very high level, what is a SIEM on Elastic? Which we start off with the rules, right? So we have 7 different types of rules we can write. And those rules run with CCS on the different partner clusters. That's also kind of the efficiency we have in our setup. So we don't have a single large cluster run all those rules on the single resource. We spread this out across all the partner deployments. And obviously really important that everything works is that we have a congruent ECS mapping throughout our deployments. And that will generate again the alerts in our core, where then the secondary system will pick it up, but I will talk about this in a moment. So the SIEM use case management, and now I added on the top our secondary system. So we don't use the case management of Kibana. We're using an external system, which is a SOAR platform. So we're picking up the alerts and then process it with the technology included with that provider. So how that looks, and I'll start a little bit from the bottom. Because Migros has such a broad structure with like over 250 companies, we need to enhance the data quite a lot. So we have various, we call them lookup tables. So starting off, for example, well, that's not really Migros related, but we also want to know for logs where they occur. So we have a lookup per document where the if that IP, for example, belongs to a cloud provider. So we're using only the major cloud providers like Azure, GCP, and their friends. We also have Migros mail domains we match against. So this is also to identify employees of Migros. Like you can imagine when you have 250 companies, for example, that you have thousands possibly of domains because Like you want to have like, especially in like the travel industry has a lot of different websites. They have their own web or email addresses. So when the logs are generated, we want to match them to the relevant companies. We also have a lookup of the Migros IP network ranges so that we can identify if it's internal traffic or external traffic. So that's also matched against every single document we ingest. Company names, like this really complicated effects. So like when you have subsidiaries of a Migros company, you can have like inheritance, say like there's a three-person company, which is owned by another company, then owned by another company, and then owned by MGB. So you need to know like that tree of belonging, and that is what we also include in that lookup table. Then we have Migros users. We have a lot of identities. Like the staffing itself is like around 100,000. There's a lot more identities, and then we need to look up the single identities against and make them unique so that people with 2 or 3 accounts can be mapped to one single account. We also have the EDR inventory inside of that lookup setup. And we also manage here global exception lists for some parts. So for example, when we have deployed rules, we want to have automated generate exception lists for certain parts. In that specific example, like network ranges of, say, test infrastructure, which then automatically deducted from the alert rules. Then we also have our own threat intelligence hub. So we also, next to all the other detection technologies we use, we have our own threat intelligence cluster where we curate all the data. And then we also have rules based on that. So currently, like we focus on domains, IP addresses, and URLs. Obviously, a lot more is possible, but those who work with the lookup capabilities of Kibana know what the limitation is. Like you have like a performance issue when you have too many lookups per document. So hopefully there's going to be some improvement there as well. Like I know you're gonna nice. We're going to look at you for a lot of things you can't do anything against, but nice. Okay. And then we have, like, as Roger already mentioned, like different repositories which hold configurations. So for example, all our shared like exception lists, trusted application, event filters, block lists, the host list isolation, exceptions, and agent versions is all managed in that repository. So we can either share this across one or many clusters, or have this like as a singular setup for a single cluster where we manage those exceptions. So it's normally edited in the UI and then extracted and then pushed into the repository and then made as part of the configuration to redeploy whenever we need it. We also have in that setup the SIEM core configuration, which are like the various parameters to control the function and the access and also like other parts of Kibana, which we manage also inside of a repository. Part of what we would like to show is then also our SIEM core use case Git repository. So that holds all the details relevant to a SIEM use case, which, for example, are external references, so mail templates, link also to Elastic dashboards. So you can imagine that you have an alert rule. You can, in an alert rule, have references, but we extracted that into the configuration separately so that we can have, say, analyst dashboards to an event, which is also linked. We do that way so we can consume that with an external platform. We also have the playbook association, which is actually another repository. They're like all the run sheets inside and also the automation references. And then also the SIEM use case themselves. So in there we have a folder structure which is organized by technique name. So you have like those 11 or 14 different technique names, and then under that you have the different SIEM use case names, which function with us as IDs. And in that folder, then you have rules, rule exceptions to that particular SIEM use case, testing, YAML file, and enrichment queries. Also in our automation platform, we have the possibility. So when an alert is generated, it's similar actually to what Timeline does. So you can gather more information and pull them back. And so this is also like pre-written. So when an alert occurs, you can actually enrich that data set with enrichment queries, which we have written for every single use case. So that roughly looks like that. We have, for the SIEM use case, a YAML definition. This is something we have defined. It's not something which is provided by Elastic. We use that prior to manage our roadmap design. So we pull those YAML configurations to generate a roadmap we have seen before. And we also use this for our atomic red testing. So we can pull all the SIEM use case references and then test against them. And that's all managed with that. There are other ways, obviously, to do that. Maybe that's a bit too complicated, but we started off with this, and then we just kept it. And then we have the alert rules themselves. So it's like not the ND-JSON, you know, from the Kibana rule anymore. Like we extract only the rule reference. We make it look a bit pretty so that the analyst can read it in the repository. And what is important here is then the cross-cluster search part, which is then the lookup index where we run those queries against. And the structure is like that. You have like our the ID of like which is SLC, so that's the internal definition. Then you have all the different partner, which is masked as asterisks, all our partner setups. So this rule runs then on every single deployment we have. The next part is then the prod, which is the CLS environment. So also we have test environments for different deployments. We want to make sure that we only run this on the prod systems. Then we go to the index themselves, which is then the log name. Also there we can have different setups. Like we ignore then obviously the timestamps, and then we go and select only the prod streams of that. We have two orders, which is just for storage. So we also ingest data we just want to keep for compliance reasons, but we don't do any monitoring on it. But we also have like it's called onboarding. So we also have an onboarding process, and while we work on that, we don't want to generate any alerts. And with that simple definition, we can basically ignore that and only focus on the production part. And then we have exceptions, as mentioned before, which is also in that JSON formatting, as we know. This is, for example, an enrichment query we included. So that's for the particular SIEM use case. Like we run this to enrich the alert more with more event data. And then we also have our continuous testing setup, which is basically like a runner, which runs inside of GitLab. There's like two kind of tests we do. One is like an individual test. This is like per SIEM use case test definition, what I mentioned before. And the other is an atomic red test. And this is like in the sake of easiness, we have done a test setup. I will show you afterwards an example of that, how that looks. Like it's a YAML definition, so an engineer can define what needs to be tested against. So what needs to be discovered, what it has to be the outcome of an alert. And then you also provide log samples to actually produce that. For those who don't know Atomic Red, like it's a library with different rule sets you can, or like a text you can run against. And then we use this as a continuous testing infrastructure. So we can either run this on a schedule, so it's like for the continuous testing parts to make sure the alerts fire and work. But you also can use a single use type of testing. For example, when we are on development cycle, you want to actually make sure that what you developed is also firing. The difficulty here is obviously like atomic red doesn't always match like your environment, or doesn't always match, like the rules can be too easy or too complicated. So sometimes you need to adjust for that. But it allows us, like the flexibility allows us actually to get some of the assurance that we test our infrastructure continuously. We run this on our own Migros environment. So it's not like a vanilla image, like we run this on a deployed VM we use internally as well. For that, we use a separate cluster. It's like the same as a partner cluster. So same configuration, same environment. And you also can actually, like the big advantage is you also can use this for sandbox testing. So you would have a system, you put an EDR agent on it, you collect the telemetry, and then you can test your rule sets against it as well. So it's, for example, if you want to test your security posture, you could use a similar setup to do that. Also on a continuous basis. Or for example, the CISO comes and says, well, do we detect that? You could actually use this setup to verify that you are safe against a particular threat. So the configuration looks like that. So you have a YAML definition, which is on the top. So the expected alert type, this what then the analyst who writes that rule defines. And on the bottom, you have then two log samples, for example, for that case. One produces a true positive and one produces a false positive. And so you have a quick way of doing tests like that. You could create obviously a more complex setup, testing is like open to the imagination of the person who develops it. But we said we want to have a bit more than the minimum, and give the assurance that at least we can check our detection technology, that we match what we want to match and we don't match what you don't want to see. So how this is deployed, very simplified. So we developed the SIEM rule inside of Kibana. You extract that ND-JSON, which looks like that. You import that into the repository. The pipelines run to clean this up, make this look readable. Does testing, verify that syntax is all right, and then it looks like that. And the cleanup, this is also what I showed before, the JSON of the ND-JSON extracted. And then you do the merge request. This is then when another engineer then looks at the rule. So you have like a normal workflow process, as you know, from similar to GitHub within GitLab, which is then approved, hopefully. And then you can run the merge itself, which then gives you then an overview what kind of feedback you get from the pipelines which run through until the final result when you have the rule active inside of the platform. We actually simplified that process because there's a few manual steps required. For example, extracting the data from Kibana. We heard that Kibana is actually, or Elastic is working on a CI/CD component where that what we built ourselves can be used. So what you need is like a trigger outside of the platform so that it can tell your repository there's a change inside of the UI, and then the data is pulled automatically. And this is what we do with our automation platform. So that the first kill the merge request and we do actually outside, so we don't have to do any manual work. But then for simplicity, this is shown like that. All right. So we go quickly and see the actual alert workflow. So we have seen the infrastructure, which is the core, the partner setup, and the interest level. So on top of that, we have our automation or SOAR solution, which collects all the alerts from our core. The Ocean automation platform picks it all up and does the correlation of the alerts and enriches everything. So whatever is inside of an Elastic alert, like we're trying to enrich documents at ingestion time, but there's also a lot of reference data. You need logic, and the logic we add, like obviously with code, and we only can do this once we defined this is an alert, and now we want to process this with the help of an analyst. So here we do like association to, for example, to other cases. We also link this to existing infrastructure components. We also have lookups on different other data streams, and that's what we do here. And the other part is also that the analyst then gets access to response actions. So for example, like do the firewall blocking, create tickets with support platforms, isolate users, or do password resets, all kind of activities which is part of the response playbook of a SIEM use case, and gives the analyst and the power to respond accordingly and have the threat isolated. So that's part of our talk. If you have any questions, and hopefully me and Roger can answer them. You can walk around. Okay.
Questions? No questions? Double microphone.
It's double microphone. Okay, thank you. Thank you for the talk. I think it was very interesting. I have a question. When you are developing a new use case and you're ready to push it to deployment, how do you evaluate the impact that it's going to have across all your customers? Like, because a use case will not impact a customer the same way as another. So how do you evaluate that and revert in case everything goes to shit?
Okay, I mean, this is part of the development process, and that's the beauty of cross-class search. So while we develop that, we don't use test data, we actually use production data, because you just can, like your queries just run on production data. So before we actually deploy this, we can run, like first we run this in the isolated system, and then we run it on single classes. And then you actually can also measure what kind of impact a rule has. But we have that experience also because we're running that operation also since a few years. So you kind of know what kind of impact it has, because you like this really nice run matrix of your use cases. So if you know that, like say your average rule runs like, I don't know, like 200, 300 milliseconds, then you know that whatever you write will be in the range of that. So impact of our rule set is actually very limited part of those data streams which contain a lot of data. So let's say firewall logs. So whenever we touch that, we're really careful that we don't test something on the production system, that it first verify, and like you can do easy calculations there as well to say, look, we look up, say, or we do a query on 1 million documents. What happens when you do this on 10 billion or on 100 billion? So that's actually something we can fairly easily control.
More questions? Otherwise, I have one. You mentioned you convert the data to ECS. How do you ensure most of the data is at least half in ECS?
This is part of the onboarding process. So when we there's two types of ingestions we do. Like one is just storage, then we take the message block and the timestamp, and then we just basically move it into frozen as quickly as possible. And the other part is where we actually map the data. So it goes through 2 lines of review. One is with the onboarding team, and one is then with the CDC team. And that's and we have a guide where we say, look, these are the relevant fields we need to map against. So It's like a 2-layer approach where we verify that. It's costly, like it takes so much time to actually review everything, but we need to do that to make sure that the quality is right. Yeah. And there's no integration which you don't have to review. That must be really clear. Like we do that on every single log feed.
Any more questions? Thank you very much.
Yeah, thank you.